So next, so that is basically the motivation for building IPVPNs. Now let us look at some of what VPN and its properties are. What is the definition of a VPN? So a VPN is nothing but a private network service built on a service provider shared infrastructure. What is the virtual part of this? It just means that it appears to be a separate physical network to the customer, but actually it is sharing the hardware resources of the service provider. Then what exactly private means? Each VPN customer maintains its own routing information. The VPN customers are not even aware that there are a lot of other customers who are leveraging the same service provider resources. So they feel that they are on a private network. So that's basically the definition of a VPN. As we talked about, the key drivers are the cost effectiveness, the flexibility, and the simplification. VPNs, as we'll see in the next few slides, they can be built at layer 2 as well as layer 3. We'll see the pros and cons of both these approaches. So what are some of the key features of VPNs? Let us look at it from the viewpoint of a customer who is buying VPN service from a service provider. Basically what he wants is one routing domain per VPN, and he should be able to use any routing protocol. If the customer is always using OSPF, he would prefer to continue to use that. If he's using RIP, he wants to continue to use that. Things like that, right? If he's using EBGP, he wants to continue to use that. He cannot change the kind of network that he has just because he wants to buy the VPN service from the service provider. So you need to retain all that. And then the customer would want the flexibility of using his own route maps for transferring routes from one place to another. He wants to build intranet and extranet kind of services. And a typical example of this would be that you can go to any company's website and you will see only that information that is really consumable by the public, not any something which is proprietary to the company, some information that you should not be able to see. And the VPN customer also wants to have firewall capabilities, in the sense he wants to be able to control what kind of traffic comes into his network and things like that. And it's also that the VPN customers want to reuse some of their existing IP addresses. If there are different VPN customers, the service provider can build a network in such a way that both the customers can continue to use the same IP address. It won't affect anything. We'll see how that MPLS IP technology helps achieve this particular thing. Then the most important thing is security, where it should not be possible for one VPN to access the resources of another VPN. This is one of the most important things that all VPN customers look for. And then another key feature is that the C routers need not be routing peers. I mean, this is mostly applicable in the peer-to-peer model. And the VPN customers also want the flexibility of having their own kind of QoS depending on the requirements. Like, for example, if a company wants to connect the head office to its branch office, it might want a different kind of QoS versus a bank which might want to do some wire transfer to some of its branch offices. So the kind of requirements for QoS are different. And here we notice that the layer 1 and layer 2 resources are now administered by the service provider. So what are the different models of IPVPN that a service provider can adopt to provide these kind of services? So typically there are two models. One is the overlay model, wherein the service provider provides only emulated leased lines to the customer. And the second model is called as a peer-to-peer model, wherein the service provider and customer exchange layer 3 routing information, and the provider relays the data between the customer sites on optimum path without the customer's involvement. At a high level, let me tell you what the differences are. In the overlay model, basically the service provider is saying that, hey, here, take one lease line. It could be an ATM circuit, it could be a frame layer, or whatever that might be. He's providing layer 2 services, and he's going to map that onto his MPLS within his network. And all the routing problems are basically the concerns of the VPN customer. So a lot of customers prefer that. Now there is, in the peer-to-peer model, what happens is the customer will say, hey look, I just want to be able to deal with problems on my direct connection to the service provider, and it's your responsibility to connect me to my remote sites. So basically the routing problems are the problems of the service provider now, and it's not the customer. Now both these approaches have its pros and cons, and let's see what they are. So in the overlay model, as I said, there is a clear separation between the customer and the service provider's responsibilities. The service provider provides the customer with emulated lease lines called virtual circuits. In this particular case, the service provider has no knowledge of the customer network, because all he's concerned is, I'm going to provide you a lease line and I'm going to charge you for the amount of usage. And it is the job of the customer to establish its communication to all the remote sites over these particular emulated circuits, and the routing protocol data is exchanged between the customer devices. As I said, the service provider has no knowledge of how the customer has built the network, how many routes he is using, and things like that. The billing is purely based on the lease line that he has provided to the customer. In this particular case, it is hard for the service provider to provide multiple classes of QoS because it cannot differentiate the traffic in the middle of the network. One thing we have to be careful here is in understanding this particular scenario is that the service provider is providing the service to multiple customers. So since he's not aware of the kind of traffic, he'll not be able to optimize his network. Right? So that's the most important thing to keep in mind. So how does this work? So this